Welcome to ECS DNS integration. Welcome to our comprehensive presentation on AWS ECS and DNS services integration. Today, we'll explore how Amazon Elastic Container Service works seamlessly with various DNS solutions to provide reliable service discovery and networking. This presentation will take you through the fundamental concepts, practical implementations, and real-world scenarios where ECS DNS integration becomes crucial for modern containerized applications. Whether you're running microservices, web applications, or complex distributed systems, understanding DNS integration with ECS is essential for building robust, scalable architectures. DNS fundamentals in container orchestration. Before diving into ECS specifics, let's understand why DNS is so critical in container orchestration. In traditional deployments, you might hard-code IP addresses or use static configuration files. However, containers are ephemeral by nature. They start, stop, and restart frequently. Their IP addresses change constantly, making static configuration impossible. DNS provides the abstraction layer that allows services to find each other using human-readable names instead of IP addresses. This is especially important in microservices architectures where services need to communicate reliably. ECS leverages DNS to enable service discovery, load balancing, and seamless communication between containers across different availability zones. Let's examine the ECS DNS architecture overview. This diagram shows the high-level relationship between key components, outlining how DNS works within the ECS ecosystem. At the foundation, we have Route 53 as AWS's managed DNS service, which can resolve both internal and external queries. Above that, we see ECS Service Discovery, which automatically registers and deregisters services. The application load balancer acts as the entry point for external traffic, while internal services communicate through private DNS names. Within the VPC, each ECS task gets automatically registered with DNS, and when tasks are terminated, their DNS records are automatically cleaned up. This creates a self-managing DNS ecosystem that scales with your application. Route 53 Service Discovery Deep Dive. AWS Route 53 Service Discovery is the cornerstone of ECS DNS integration. It automatically creates and manages DNS records for your ECS services without manual intervention. When you create an ECS service with Service Discovery enabled, Route 53 automatically creates A and SRV records. The A records point to the IP addresses of healthy tasks, while SRV records include port information. The beauty of this system is its automatic health checking. If a task becomes unhealthy, Route 53 automatically removes it from DNS responses, ensuring traffic only goes to healthy instances. You can configure TTL values to control how long DNS responses are cached, balancing between rapid updates and reduced DNS query load. Creating service discovery step by step. Let me walk you through the exact commands needed to set up service discovery for an ECS service. This is the practical implementation you'll use in real projects. First, we create a private DNS namespace. Think of this as your internal domain for service-to-service communication. The AWS Service Discovery Create Private DNS Namespace command establishes this foundation. Next, we create a service within that namespace. This defines how your application will be discoverable by other services. The health check configuration ensures only healthy instances receive traffic. Finally, when creating your ECS service, you reference this service discovery service, and ECS automatically handles all the DNS registration and deregistration as tasks come and go. Internal versus external DNS patterns. Understanding the difference between internal and external DNS patterns is crucial for designing secure, scalable applications. Internal DNS, shown on the left, uses private hosted zones within your VPC services like API, internal, and database. Internal are only resolvable within your private network. This is perfect for microservice communication. External DNS on the right uses public hosted zones and is accessible from the internet. Your load balancer typically sits here, providing the public interface to your application. The key insight is that most of your services should use internal DNS for security, while only your entry points need external DNS. This creates a secure perimeter around your application. ECS Service Discovery in action. This diagram illustrates how ECS Service Discovery creates a dynamic, self-healing DNS system. Let's trace through what happens when you deploy a new service. When ECS starts a new task, it automatically registers the task's IP address with Route 53. The DNS record becomes immediately available for other services to discover. If a task fails, health checks, ECS notifies Route 53, which removes the unhealthy task from DNS responses. This happens automatically without any manual intervention. When you scale your service up or down, DNS records are automatically added or removed. This creates a truly elastic DNS system that matches your application's scaling behavior. Advanced DNS configuration options. ECS provides several advanced DNS configuration options, allowing you to fine-tune how your services discover and communicate with each other. Custom DNS suffixes allow you to organize services logically. For example, you might use API prod my company local for production API services and API staging my company local for staging. TTL configuration controls how long DNS responses are cached. Lower TTL values mean faster failover but higher DNS query load. Higher TTL values reduce load but slow down failover. Health check configuration determines how quickly unhealthy services are removed from DNS. You can adjust the failure threshold and check interval based on your application's needs. DNS integration with load balancers. Load balancers play a crucial role in ECS DNS architecture, acting as the bridge between external clients and your internal services. The application load balancer typically has a public DNS name that external clients use to reach your application. Behind the scenes, it uses ECS Service Discovery to find healthy backend targets. You can configure multiple target groups, each pointing to different ECS services. The load balancer automatically discovers these services through DNS and routes traffic accordingly. Health checks at the load balancer level work in conjunction with ECS health checks to ensure traffic only reaches truly healthy instances. Let's look at practical examples of how to implement DNS integration in real ECS deployments. These are the actual commands and configurations you'll use. The task definition shows how to configure your containers to work with service discovery. Notice how we don't hard code any IP addresses. Everything uses DNS names. The ECS service configuration includes the service registry's parameter, which links your service to the Route 53 service discovery service we created earlier. The great thing about this setup is that once it's configured, it's completely automatic. Your applications just use DNS names, and ECS handles all the complexity behind the scenes. Troubleshooting DNS issues. Even with automatic DNS management, issues can arise. Let me share the most common problems I've encountered and how to resolve them. DNS propagation delays are often the first issue you'll face. Remember that DNS changes aren't instantaneous. They can take several minutes to propagate throughout the system. The dig and nslookup commands are your best friends for debugging DNS issues. They let you query DNS directly and see exactly what records are returned. CloudWatch logs for ECS and Route 53 provide detailed information about service registration and health check failures. Always check these logs when troubleshooting. Let's discuss performance optimization strategies. DNS performance can significantly impact your application's responsiveness. All share strategies to optimize DNS performance in ECS environments. A crucial strategy is caching. Configure appropriate TTL values for your DNS records. If the value is too low, you'll overwhelm your DNS servers. If it's too high, failover becomes slow. Consider using connection pooling and keep alive connections to reduce the number of DNS lookups your applications need to perform. For high-traffic applications, consider using Route 53 Resolver for improved query performance and reduced latency within your VPC. Security best practices. Security should be a primary consideration when implementing DNS in ECS. Let's discuss the key security practices you should follow. Always use private hosted zones for internal service communication. This ensures that internal service names are not exposed to the public internet. Implement proper IAM policies to control which services can register with DNS and which can query DNS records. Principle of least privilege is crucial here. Consider using VPC endpoints for Route 53 to ensure DNS queries never leave your VPC, adding an extra layer of security. Regularly audit your DNS records to ensure no unauthorized services have registered themselves in your namespace. Monitoring and observability. Monitoring your DNS infrastructure is essential for maintaining reliable service discovery. Here are the key metrics and tools you should implement. CloudWatch provides metrics for DNS query volume, response times, and error rates. Set up alarms for unusual patterns that might indicate issues. Monitor service registration and deregistration events to ensure services are being discovered correctly as they scale up and down. Use distributed tracing tools like AWS X-Ray to track how DNS resolution impacts your application's overall performance. Set up alerting for DNS health check failures so you can respond quickly to service degradation. Cost optimization strategies. While DNS costs are typically small, they can add up in large-scale deployments. Let me share strategies to optimize these DNS-related costs. Route 53 charges per hosted zone and per query. To reduce the base cost, consolidate services into fewer hosted zones where possible. Optimize TTL values to reduce query volume while maintaining acceptable failover times. Longer TTLs mean fewer queries and lower costs. Use Route 53 health checks judiciously. They're powerful, but each health check has a cost. For basic scenarios, consider using ECS health checks instead. Monitor your DNS query patterns and eliminate unnecessary queries through better application design and caching strategies. To summarize and outline our next steps, we've covered a comprehensive journey through ECS DNS integration, from basic concepts to advanced optimization strategies. The key takeaway is that DNS in ECS isn't just about name resolution, it's about creating a resilient, self-healing infrastructure that scales with your applications. Start with basic service discovery for internal services, then gradually implement more advanced patterns like multi-region DNS and complex routing policies. Remember that good DNS design is the foundation for scalable microservices. Invest time in getting it right early, and your future self will thank you. The next step is to implement these concepts in your own environment. Start small, monitor carefully, and iterate based on your specific needs.